In this lecture video, we will understand what is processing topology or what does processing topologies mean. So processing topology, it means where the data is processed in an IoT system. That is, on-site processing means data is processed near the place where it is generated and usually on the device itself or a nearby edge device. Now, instead of sending data to a distant cloud, the server or the system analyzes it locally, and this allows faster response and real-time decision making. So when sensors collect data, we must decide, should we process it to the nearer the device or far away from the device, that is the cloud or the server. Now here we can divide the various processing solutions into two large topologies. First is the on-site topology and second is the off-site topology. And the off-site topology, it is further divided into two types, that is the remote processing and the collaborative processing. Now first we will see what is on-site processing. So here on-site processing, it is also called as edge processing, where the processing happens close to where the data is generated, that is nearer to the sensors or the devices. Now in edge processing, the data is handled near the sensors or the devices like microcontrollers, gateways or edge computers. Because the data does not travel far, the system can react quickly, and this is very useful for real-time IoT applications. Next is how this works. So here the sensor collects the data. So the sensor measures physical values and such as temperature, water level, motion or humidity, and the sensor continuously sends this data to a nearby device, and this is the first step in the processing system. Second is the local device, or that is the microcontroller or the edge device, where it receives the sensor data and analyzes it immediately, and it uses the programmed rules or algorithms in order to decide what actions should be taken. And this processing happens locally without sending data to the cloud. So next point is immediate action should be taken, or immediate action is taken, where after analyzing the data, the system quickly performs an action such as turning on a motor, okay, or activating an alarm or adjusting a device. Since processing happens locally, the response time here, it is very fast. One real-time example is a smart water tank here. Now in home, sensor will measure the water level and microcontroller checks the level. So automatically the motor will turn on or off. So here no internet is needed and the response is very fast. So here what happens is this smart water tank system automatically controls the water motor using the sensor and a microcontroller, and it helps prevent water overflow and dry running of the motor. And the sensors, these will measure the water level, that is, they will detect how much water is present inside the tank, and it continuously sends the water level information to the controller. And the microcontroller compares the water level with the predefined limits, and if the level is low or high, it decides what action should be taken. So when the water level becomes low, the system automatically turns on the motor to fill the tank, and when the tank becomes full, it turns off the motor to stop the water flow. Here no internet is needed because the edge processing works without internet connection, because the processing happens locally, and the device itself makes decisions based on sensor data, and this makes the system useful even in the remote areas or the offline environments. And also it has a fast response. Since the data does not travel to the cloud, the system responds almost instantly, and this low delay is called as low latency, and it is important for applications that need immediate action. Some advantages are, it is very fast, that is low latency, because here processing happens close to the device, so the response time is extremely quick. This is important for real-time systems like automation, robotics and safety systems, and it works even without the internet, that is, the edge devices can operate independently without relying on the internet connectivity. This makes them reliable in rural areas, factories, or the remote locations. Then it saves the bandwidth because the data is processed locally. Only important information needs to be sent to the cloud. So because of this, it reduces the network traffic and the internet data usage. And third is, last is, it is more reliable because the local processing reduces the dependency on network connectivity. Even if the internet fails, the system continues to function normally. Now some limitations are, it has limited processing power because the edge devices like microcontrollers, these have smaller memory and the processing capability compared to the powerful cloud servers. This limits the complexity of the task they can perform. Then it cannot handle very complex analytics because here the advanced data analysis such as big data processing, deep learning, or large scale analytics requires powerful cloud systems, and the edge devices are usually designed only for simple and quick decisions. So this is about the on-site processing or the edge processing. Next comes the off-site processing, where the data is sent away from the device to a central system, that is the cloud or the server. Now here we have seen that it has two types. One is the remote processing, another is the collaborative processing. So in remote processing, all the processing happens in a central cloud or the server, and here the sensors will collect the data, that is these devices will continuously gather information such as the temperature, heart rate, or location, and this raw data is not processed locally, and the data is sent via the internet, where the collected data is transmitted to the cloud using the internet connectivity, and this requires a stable network connection. Then the cloud processes the data, where the powerful servers analyze the data using advanced algorithms, and complex computations are handled easily in the cloud. And the last point is result is sent back. That is, after processing, the results are sent back to the device or the user so that the user can view the insights through apps or the dashboards here. So sensors will collect the data, then it is sent via the internet, cloud will process the data, and result is sent back through the apps or the dashboards. Now one real-time example here is the fitness band, where the band collects the heart rate. That is, the fitness bands continuously measures the heart rate using the sensors, and the data is collected in real time. And the data, it is sent to the mobile cloud here. Okay, data is sent to the mobile or the cloud. That is, the data is transferred to a smartphone or a cloud server, and the internet or Bluetooth is used for the communication. Then here the apps shows the graphs and the analysis. It means that the app which we are using in the dashboard or the mobile phone, it processes and displays the trends like daily activity or health reports, and user gets meaningful insights from the raw data. So heavy processing is done in the cloud but not in the device. Now some advantages of this remote processing is high processing power, because the cloud systems have powerful processors and they can handle complex calculations efficiently. And second is, these can analyze the large data or huge amounts of data from many devices, which can be processed together, and it is useful for big data analytics and the predictions. Then last is the long-term storage, where the data can be stored for a long time in cloud databases, and the users can access past records anytime. Next comes the limitations. It requires the internet because the system depends on the network connectivity, and without internet, processing cannot happen. Then next is the latency or the delay, where the sending data to the cloud and receiving results takes time, and it is not suitable for real-time critical applications. Last is the more bandwidth usage, where the continuous data transfer consumes network bandwidth, and this may increase the cost and the network load. So the second type of offsite processing is the collaborative processing, where this processing is shared between the edge, that is the device, and the cloud. So here some work is done locally and some work is done in the cloud. Now here the device does the quick or basic processing, where the initial filtering or simple decisions are made locally, and this reduces the unnecessary data transmission. Then important data has to be sent to the cloud. as only useful or critical data is transmitted to the cloud. This saves the bandwidth and improves the efficiency. Third point is the cloud does the deeper analysis, where the cloud performs the advanced analytics and long-term processing, and this generates insights and optimization strategies. So here one real-time example here is a smart traffic system. So now here you can see at the traffic signals, the camera will detect the vehicle. That is the basic processing locally, and the cameras identify the vehicles and count the traffic at the signals, and quick decisions like signal switching can happen locally. Then next is the data is sent to the central server, where the traffic data is forwarded to a central control system, and this allows the monitoring across the multiple locations. And the server, it analyzes the traffic patterns there. That is, the system studies the congestion, peak hours, and the flow trends, and advanced analytics helps in decision making. Then it will adjust the signal timing across the city. So based on the analysis, the traffic lights are optimized, and this improves the overall traffic movement in the city. Now advantages here are the balanced performance, which combines speed of local processing and the power of cloud, and provides efficient overall system performance. And then second is it is faster than the cloud only. It means quick decisions are taken locally without the delay, and it reduces the dependency on cloud for every task. Third point is the efficient use of bandwidth, where only necessary data is sent to the cloud, and this reduces the network load and the cost. And the last is scalable, where here the system can easily expand by adding more devices. So the cloud handles increasing data efficiently. Now coming to the limitation here, more complex system design. It means that it requires proper coordination between the device and the cloud, and designing and managing such systems, it is very complicated. So this is about the processing topologies.